let's look at this. We need to find the derivative of the following using the first principle. Okay? Okay, say for number 1. For x, what we need to do, we say y is equals to x. We say this is the first equation. Then we are going to increase this now by delta y equals to this by delta x. Okay, that is the second point, the one you saw as q. So we're going to subtract, let's call this one 2. Now we're going to subtract 1 from 2. That is, for the left hand side, this minus this. For this side is this minus this. That is q minus p. If you have been following this class from the first lecture on calculus, you need to go and watch all the videos before this class. Otherwise, you might be confused of what I'm doing by writing q and p. Some of you will be saying, what is p and q? Because you did not watch the previous video, okay? So with this now, this and this will strike out. We have this as equals to this and this will strike out. We have this, okay? We divide both sides by delta x. This one, this one. Therefore, our answer here is equals to 1. Now, this is not differentiation. To bring in the differentiation now, that is dy over ds, we say it's equals to lim. You must put this, so you must put it, okay? Lim. And this is going towards 0. This one, okay? You say it's equals to lim this to 0. What is this here? It's 1, right? You put the 1 here. It's actually equals to 1. This is how to do the final expression using the first principle. Okay? One thing I want you to notice here is this, very important. If we go back to this place now, just x, how is this one? You agree with me that for this now there is 1 here, indices. If you have not watched indices class, go and watch the video. Now for this to be 1, what we did is this 1 multiplied by s raised to the power 0, which is 1 multiplied by 1 equals to 1. Because this is 1. You get it? Indices. Now, this is what we are going to get for this. That is, we put the 2 here, we reduce this by 1. Because we also reduce it by 1 to have 0. This one I was here before, we put it here. We say 1 minus 1 to have 0. That's how we got that 1, okay? For this one now, we remove 1 again. The 2 that was here, we bring it down, become 2 raised to the power 1, which is 2x. This is what we are going to get for this second one. So let's go for the second one, s squared. S squared, okay? For the second one, it's s squared. That is y equals to s squared. Then that is this, equation 1. Then this plus delta y equals to this plus delta x. Remember, this delta is for x. It's like the food you eat into your body. So we must put it like this. I put 2 here. Why am I saying that? Some students might be confused. Oh, why are we putting? Why not do it like this? No. If you do it now, that means this guy is outside x. We are talking about the increase or the increment of x. So this guy was like increase. Make you fatter. That 2 will still retain the 2. What is this therefore? This is also an equation, equation 2. We remove 1 from 2. That is, for the left hand side, we remove y. That is this minus this. Therefore, this side, this minus this. That is, whatever I said before, minus this. So this and this will go. It means we have delta y equal to this, that is, we expand this, that is, s plus this, s plus this, minus this. This will give us this and this s squared plus this and this s delta s plus s delta x plus delta s square minus s square. Okay. So you can see in this place now, this and this will cancel. Okay. With that now we have equal to, this is what, 2s delta x plus this square. Okay, we cannot bring in this. So the next thing is to divide here by this. I also divide this side by this because that's what we are looking for. Changing y over changing x. Hope you are getting it, okay? Now, we come to this place. If we divide this now, we have 2x here. Plus we divide this, what is remaining is delta x. Okay? Now, we are good to go. So the y, the s now, which is the differentiation we are looking for, the derivative, is equal to limit as delta s is going towards 0, delta y over delta x, that is for this, that is the meaning. This is the meaning of the y dx. So the next thing we need to do now is to go back and say the y over the x, to say the y over the x is equals to this limit as this guy is going towards 0. What is this now? That is this. We use this one to replace it. That is 2s plus this. So the next question now is, what do you think if this is going towards 0? What is this going to be? Becomes 0. It means this one without this disease, let's call it disease, or this one without this infection will not be affected. Only this guy will be affected because what is delta s that is going towards 0. So what is remaining for us now becomes 2x. So this is the answer. So let me remove all these. You can see exactly what I told us before, that we are going to have 2x. Okay, as you can see, we have 2s for s squared. That is the derivative of s squared using the first principle. S squared using the first principle. This 2 comes here. We reduce this by 1. That is 2 minus 1, which is 2s raised to power 1 equals to 2x. Please pardon me. I write my s like this. Sometimes I write it like this. Okay. Hope this understood. Thank you for viewing.